Hello everybody and welcome to today's lesson on transformations. Today our objectives are we will solve problems involving symmetry and transformation. We will determine whether a figure is symmetric with respect to a line or a point. And we will determine whether a figure has been translated, reflected, rotated, or dilated using coordinate methods. Let's first talk about some vocabulary. A transformation occurs when a figure changes or moves. The figure before the change we call the pre-image. Pre as in before, that's before we make an image. And the figure after the change is the image. And a figure that does not change size or shape is called an isometry. Isometric transformations are translations, reflections, and rotations. A dilation is not an isometric transformation because the object changes its size. In fact, that's what a dilation is all about, changing size. And we have discussed dilations in Unit 5 when we talked about scale factor and ratios of lengths, areas, and volumes. Today we will focus on the isometric transformations, translation, reflection, and rotation. A line reflection is the mirror image of the figure over a line. And that line is also called the line of reflection. And mirror image, think about that line of reflection as being a mirror that you look into and then you see your image on the other side. Let's look at our picture on the left. We got our pre-image, our triangle ABC, and that triangle is reflected over this vertical line to create an image. Think about this vertical line as a mirror you look into, and on the other side an image is created. In this case it's the image of the triangle A prime, B prime, C prime. The points that are created of an image we call prime. So for example A prime. And just like when you look into the mirror in the morning as you get ready for school, points that are close to the mirror also appear closer on the other side, and points that are far away also appear further away on the other side. Point A is very close to the mirror, so A prime is also very close, and point C is very far away from our line of reflection, which is kind of like our mirror, and therefore point C prime is also very far away and an equal distance away from the line of reflection. Very often we have to create a reflection over a certain line in a coordinate plane. It could be the x-axis or it could be the y-axis, and then we just count an equal number of steps to the right as we count to the left, or up and down. But when we reflect over the line y is equal to x, as in this example with the quadrilateral, what I want you to remember is that the x's and the y's will switch places. The line y is equal to x is a very important line. Remember, it's our first diagonal here in the coordinate plane, and reflecting over a diagonal, we have to remember that x's and y's are going to switch places. And the best way to do that, for in the example of this quadrilateral, just count how far is each point away from the line of reflection in the x direction. Like this point is 1, 2, 3, 4 steps away. And then we switch. And instead of continuing going into the x direction, we now go into the y direction. 1, 2, 3, 4. And there is our first point. And now let's keep doing that for the other points. 1, 2, 3, 4, 5, 6, 7, 8, 9 steps to the left. Means now we have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 steps up. And here is our second point. Let's continue onwards. 1, 2, 3, 4, 5, 6. And now up 1, 2, 3, 4, 5, 6. And our last point is 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. And now 1, 2, 3, 4, 5, 6, 7, 8, 9 steps up. And now we connect our 4 points to get the image of our quadrilateral. And what you can do is tip your head to the right, and you see how those two objects nicely are reflected from each other across our diagonal, across our line y is equal to x. Let's talk about symmetry. A figure has line symmetry if it can be cut into two identical pieces by a line. Some figures have more than one line symmetry, or they can have no lines of symmetry at all. Let's look at our 3 triangles here. Our first one to the left is an isosceles triangle with 2 congruent sides, and we can cut it right in the middle. And if we do this, we get 2 halves that look identical. So this one has 1 line of symmetry. And then let's move over to our next one. That's an equilateral triangle. Why don't you have a look, stop the video, and think about how many lines of symmetry you see, and then we'll talk about it. Okay, so our equilateral triangle has 1 line of symmetry here. It has another one here, and the third one here. This equilateral triangle has 3 lines of symmetry. And then our last example, a scalene triangle. As we look, we can't find anywhere that we can trace a line across that object where 2 sides are going to be equal. This one has no lines of symmetry. A figure has point symmetry when the pre-image and the image match after a rotation through a point in the center of that object. Let's look at our first object here on the left, which is a regular hexagon, right? Remember? How can we find out if this one has point symmetry? Well, let me do this. Let's just trace our object, and then we are going to rotate it and see what happens. And just so we remember, I will write here that this is the top. And now we will rotate our hexagon and see what happens. We can rotate it and keep rotating it. And as you can see, it always matches with our original pre-image, even if I'm slightly off here, all the way until we're back on top. So this hexagon definitely has point symmetry. Now spend a minute thinking about what is going to happen with our next object here, which is a star. And in the meantime, we're going to move over to our T. Does this T have point symmetry? Yes or no? Let's see. And we're going to try the same thing here. We're going to trace our T and rotate it and see what happens. As we are rotating our T, does it at any point match the original pre-image? Nowhere, unless it goes all the way back to where we start. So our T does not have point symmetry. It does, however, if we take a look, it does have line symmetry. If we put a line here across line symmetry, it does have. So at least something, right? Now let's go back to our star, and I'm sure you have figured it out in the meantime. Does our star have point symmetry? We can rotate it, and our image will always match our pre-image, no matter how far we rotate it. And we can keep doing this until we're all the way back to where we started from. So our star also has point symmetry. Okay, so much for this. And now go ahead and watch the second part of this tutorial where we'll talk about rotations and translations.